Yeah, so hello everyone. Yeah, today we are going to solve, the Gauss math AMC mock test. Let's starting with the problem of the 18. So problem 18 says three real number XYZ belong to the real number and between the 0 and the 1, inclusive, and they're chosen randomly and independently. So what is the probability of each of x minus y, x minus z is greater than negative half and less than half? Okay, so for this one, let's thinking what does this mean, right? Let's think about a two-dimensional case first. Okay, the 2D case. So let's draw x and y, right? So they randomly distributed between 0 and 1, so that's a square. We want the x minus y, right, less than 1/2. Basically is y is 0, x maximum can only take 1/2, right? And x is 0, y is take 1/2. So this is the region, right? Such that, okay, so now the problem is we have three-dimensional case now, right? So normally what we should do is solid geometry, right? So here is x, y, z, right? So each one is between 0 and 1, right? Independently. So basically there is a cube, right? So any x, y, z is just a point on any point on the cube, right? Now, similar to this, let's digest what is x minus y, right? So similarly, here's the midpoint. Let's see, it's let me make some notation. Okay, A, B, C, D, then A1, B1, C1, D1, right? So this is the midpoint of, let's see, M, here's the N, right? Here's another midpoint, and here's another midpoint, P and Q, right? So you can see because it's a solid geometry, so we must have a corresponding point or a corresponding point. Okay. Here is here like this, right? So here is the cutting, right? It's the M1, P1, P1. Right. So in the middle of this area is what we want. Basically, we are cutting off. We cut off, right? We cut off the A1, M1, P1, the A and N. Then we cut off the C, QP, the C1, QP, right? This is what we cut off. Yeah. So what's the other one? Is x minus z, right? So x and z are on this direction, right? So that means we choose another color to make it less confused. That means this one, right? Okay, so here we also have this one here, this solid. So this is the M PQ. Let's use the ABCD. Let's use EFGH, okay? Let's use the E F, right? And also we have somewhere here, right? Somewhere here, yeah. Let's draw here, right? It's symmetry, right? EF. How about I call this E1 F1, right? To make it symmetry. Something like this, right? So we also need to cut off this, right? So what you can see is we also need to cut off A M E, then B F Q, then D1 M1 E1, then C1 D1 F1, right? So this is the other two we cut off, right? Each cutoff is something like this, right? Something like this, right? So if we say, I mean, the side length is 1, right? So this is the 1/2. This is the 1/2. This is 90 degrees. This is the 2/2, right? Okay, but there is overlap between all these cutoffs, right? So we can see there is an intersection here, right? Also, you can see there is an intersection here, right? So let's focus on one corner, right? We have intersection here, we have intersection here. So now you can see, right? The overlap is just like this one, right? And there is there is another one here, right? This is the intersection, right? You can see that's this one here. Right, you can see it's this one here, right? I have another one, this one here, right? So there are two. So now we can calculating the how many intersections, right? We have one intersection, two intersections, three intersections, four intersections. So let's see. The cube, the volume of the cube is simple, right? It's 1 times 1 times 1 is 1. Then the volume of each one of this is equal to 1. I mean, is equal to 1/2, right? Of half times half, right? Then times the 1, right? How many we have of this one? We have 1, 2, 3, 4, right? 4. Now we have some overlap. This one is the overcoming, right? So the V of the overlap, OV, right? Overlap is equal to that's each one is 1/3, right? And the half of the half times half, right? Half times half is the area, right? The height is also 1/2, right? That's one of this. That's this one, right? But each one has 2, so we need to times 2, right? And we have how many such overlap? We have how many overlap we have? We have 1, 2, 3, 4, right? 4 overlaps. Okay, so now you can see that the after you cut off, the volume will be the total, right? That's 1 minus, right? The second one is 1/2, right? And the third one is what, 8. 2, 4 is 8. 1, 2, 3. That's 8, right? Is that 1 over 6? Let me think. We have how many? We have 1. Oh, I'm sorry. We have 2, because we have this part on this corner there is overlap, and on this corner there is overlap, right? So we only cutting this one and this one. So on the corner A has overlap, and on the corner C1 has overlap. Okay, so that's 12. Then what we have is 1/2 minus 1 over 12, right? So this one gives us the 12 over 5, so 7 over 12. So the answer is B, right? Okay, hopefully it's not difficult. The next one is it's called the unpainted cone. Has a radius of 3 and the slant of 5, right? So here is a 5, here the 3. The cone is placed in the container of the paint with the cone's circular base resting flat on the bottom of the container, and the depth of the paint is 2 centimeters, right? So basically, it's 4, right? This one is the cutting, the cross section, right? Is the height is 2, right? So here is 2 and 2. It's the midpoint. Then the cone is removed, its circular base and the lower portion of its lateral surface are covered in paint. What is the fraction of the total surface area, right? That is covered by. Okay, so you can think the total, right? The total is easy to calculate, right? So the total surface area is pi times 9, right? Plus, right? Then we have a slant. So when you open the when you unfolded it, right? It will be something like this. So this is the 6 pi, right? And this is a 5. So the area will be half of the 5 times 6 pi. Right, that's 15 pi, that's 24 pi. Okay, so that's the total, right? Now let's see what's the area by paint with the painting of the height. Right? So you can see that's this one, right? So basically, is this one, right? So this one is we see by half, so that's why this is the 502, 502, right? So basically, this area is painted, right? So we know this area is a quarter of is a quarter of 15 pi, right? This total area is 15 pi, right? So that's why this is a quarter. So we have the 3/4 of the 15 pi, right? Is painted plus 9 pi, right? So that's why here is painted, right? So now you want to see what is the P over Q is 9 plus 4 over 45 divided 9 divided by 24, right? So you can go calculating, right? So it's at least we can do 3, right? So it's 8, 3 plus 4 of the 15. Then it's 32 is 12, and 40, 32, 12, and 27, right? So you added them together, then the answer would be 59, right? That's the So the next one is a pair of the real number is this one, right? It's inside a pen, right? So it's 1/2 here. That's the area, right? If P is the probability that of the curve of this equation and this intersect, the intersect means right? So we want to see what kind of AB can make this satisfy, right, against the total area. Now what do we see? Here is we have the and intersect, right? So you can see what we have is 1 minus a x squared, right? Minus 2bx, right? Plus a equals 0, right? That means this existing a solution, right? That means the discriminant of the 4b squared minus 4 of the 1 minus a greater equal than 0. That means the b squared minus a plus a squared greater equal than 0, right? That means the a minus 1/2 of the square plus b squared greater equal than 1/4, right? So what does this mean? This is a circle center at here, right? The same radius of 1/2, right? So we are, by choosing this, we want the area of this one, right? So you can see definitely here is equilateral triangles, right? Because the two circles have equal radius. So let's calculating this the shaded area, right? First, the shaded area will be the equilateral triangle plus 4 of this sections, right? Sectors. So the equilateral triangle will be 2 times the root 3 over 4 times the half of the square, right? And now we have 4 sectors, right? We're calculating one sector, right? One sector is equal to the pi times the 1 over 4, right? That's the circle, 1/6 of the circle minus 3 times 2 the square. Right? So so now what's then what the 4 sectors, right? I mean basically the shaded area will be that's this one is root 3 over 8 minus 4 times the sectors, right? The sector will be pi over 24 minus 4 root 3 over 16 is equal to that's 483 root 3 minus pi over 6, right? Okay. So this is the probability. The area of this is the area. Okay. That satisfy the total area is equal to pi times half. So that's why the probability is equal to 3 root 3 over 8 minus pi over 6 over pi over 4. So times 6 is pi over, right, and 3 root 3 over 2, right? Then you can just apply the root 3 is equal to 1.7 and pi equals 3.14 to apply it, okay? Forgive me, I forget what's the answer. Okay, maybe 61. Yeah, you plug in this data, this number, and you can go calculate. Yeah. Next one. So a rectangle with the dimensions of 100 centimeters and 150 centimeters is tilted so that one corner is 20 centimeter above the horizontal. So the nearest centimeter, the height of the Z, right? So you can see the height of the Z, right, is basically, if you're cutting through here, you can see this is the congruent triangles, right? So the height of the Z is related with the angle of theta, right? So is the first part I call this M, and the second part I call N, right? So M is equal to 150, right? Times the cosine theta, right? So N is 100 times sine theta, right? And based on the trigonometry, you can see this is a 100, this is a 20. So what we have is sine theta is 1 over 5. The cosine theta is equal to 24, right? 24 is 4, 2, 6. Okay, so apply this number in, then you subtract 100 with x, right? Okay, that's for this problem. The next one is for how many positive integer k, right? This one and this one intersect the point which coordinates are positive integers, right? Basically, we are counting the x and the y, right? The solution of the x and y should belong to positive integers. So what you can do here is 9x plus 4y is equal to 600, and kx minus 4y is equal to 24. So what we can solve is the x equal to 624 over 9 plus k, right? And you must know the 9 plus k must be divisible by 624. Okay, don't forget it's positive integers. Okay. The same thing, let's solve the y, right? So when we solve the y is we can plug in back, right? So we can have the 4y is equal to 600 minus 624. Right, so let's take out this one is 150. 150 divided 156, right? So we need is 150 minus, right? So 156 times 9 divided by 9 plus k, right? So we also need the 9 plus k need to be divisible by 156 times 9, right? Let's do a further calculation is what 624 over 4 is 1, 4, 2. Okay, it's 156. Let's further to 156. 4. It's 4 squared times 3 times 13, right? This one is 3. This is the 2, 4 times 3 times 13. This one is 3 power 3 times 4 squared 2 to the 2, right? Times 13, right? So basically, the 9 plus k and 9 plus k need to be factor of this and this. That means 9 plus k need to be the greatest common divisor between the 2 to the top 4, 3, 3, 3 power 3, 2 to the 2 of 3. This one equal 2 to the 2 and 3 and 13. Right? Okay. So we know, I mean, there are how many factors here? It's 3 times 2 times 2 is 12 factors, right? But remember, k is a positive integer, right? So the 9 plus k should at least greater equal than 10, right? So any factor less than 10, it doesn't count, right? We have 1, 2, 3, 4, 6, right? So it's 1, 2, 3, 4, 5, right? So 12 minus 5, 7. So the answer is there. Okay. Next. So we n be the number of triples x, y, z of positive integers. Okay, x, y, z belong to the positive integers such that x less than y less than z and x, y, z is what? Is okay, all the prime numbers. 2, 3, 5, 7, 17, 17, 19. What is the n divided by 100, right? So now you can think, right? So the x y z must be 2 of the, let's see, 2 of the a1, right? How many? 1, 2, 3, 4, 5, 6, 7, 8. That's 8, right? 2 of the a1, then 3 of the b1, 19 of 8 is h1, right? Now y is 2 of the a2, right? 3 of the b2, right? Then 19 of the h2, right? If this is the case, z must be equal to 2 of the 2 minus a1 minus a2, right? To 19 of the 2 is h1 is h2. So, so that means without any constraint, right? Without any constraint, right? Because we need the distinct, right? And let's stay without any constraint, right? Without constraint, right? It's basically stars and bars, right? So what we have for each one is what is 2 plus 2, pick 2, right? And we have 8. So that's 6 power to the 8. Okay. The next one is we need to subtract what if the 2 are equal, right? For 2 are equal, basically we have 3 ways to pick 2, right? To be equal, right? Now let's say A1 is equal A2, then what we would have is 2 of the A1, right? Plus A3 is 2, right? And we have the 2 of the B1 plus B3 equal 2. Right? So these are say without a loss generality, we can say A1 equals A2, right? Because we have multiplication here, right? Okay, now let's count each one, right? So if A1 equals 0, right? Then A3 can equal 2, then A1 equals 1, then A3 equals 0. So these are the only case, right? For each one, there are 2 cases, right, to make them equal. So 2 of the 8. So here is we need to subtract 2, then 2 of 8. Right? So after subtracting this case, the rest of the case must be x doesn't equal y, that doesn't equal z, right? There is no equal, right? But so each of them, there are 6 ways to permutating, right? So that's why the n should be 6 power to the 8 minus 2 to the 8, then divided by 6. Then this should be the 6 power to the 7 minus 2 to the power of 7, right? So now you need to mod this one by 100, right? Okay. So basically, you can keep calculating, right? It's 2 to the 7, 3 to the 7 minus 1, right? By 100, what is the 3 power to the 6, right? It's 9 to the 3 is 729, right? And 729, 100 is only 29, right? Then another 7 is 29 times 3, right? Is equal to 87. Then 86 times the 128 is equal to 28 times 86. What's 86, 28? So 8, 0. Okay, so the answer is C, right? Yeah. So this problem, next problem is there are function fx in the following properties such this one, some integer ABC with a greater than 0 and fp equals fq equals 17, p plus q equals 47 for some prime numbers p and q. Okay, so find all the values of pq. So basically, we know the fpfq on this. This is the quadratic, right? So we know the pq, right? PQ are equal, right? So the center must be on the half of the PQ, right? Must be something like this. And the symmetry here, right? This is 17. So you can see the P plus Q, right, is just the same distance. So that means it's also symmetry here, 47 and 47. So what we have, C equals 47, right? That's the first way we can decide, right? Okay. If C equals 47, basically we already satisfy this one, right? PQ are prime number we are going to see, right? FP and FQ equals 17, right? So now what we have is if C equals 47, we already have this. Now let's see what can we have. Okay, let's see A of the P squared plus B times P plus 47 equals 17. And A of the Q squared plus B times Q plus 47 equals 17. Right? That's the two equations we can have, right? So and what we get is what is A P squared plus BP equals minus 30 equals 0, right? So basically, this one, this quadrilateral has two roots, right? P and Q. So we can write as x minus P, x minus Q, then equals ax squared plus bx minus 30, right? So from here, what we can have is the negative of the A of the P plus Q, right? X, right? Plus the APQ is equal to BX minus 30, right? Plus 30. Sorry for the calculation error. Okay. Plus 30. So in this case, what does it mean? That means the APQ equals 30 with A greater than 0, PQ a prime, right? So this becomes the prime factorization, right? 2 times 3 times 5, right? So PQ a prime, basically we can make a list, right? Because P and Q are symmetry here, right? So we just need to consider what is the PQ times together. It doesn't matter of the order, right? So let's see, assign PQ 2, 3, 2, 5, 3, 5, right? So A is 2, A is 5, then A is 3, then A is 2. So in this case, let's list P plus Q is 6, 7, and 15, right? And A, then we need to list the B, right? B is A times P plus Q negative, right? Negative 30, negative 21, negative 30, right? So hopefully with that, right, everything is determined, right? You know the A, you know the B, so the quadratic is fixed. You know the P and Q, so you can go calculating the times PQ, right? Let me list another one. Is PQ is 6, 10, 15. Okay, so P plus Q is 8. Sorry. the negative 16, right? Okay, so the next step, hopefully you can do by yourself, right? Okay. Final question is 3 by 3 grid is shown the central square is contains integer 5. The remaining 8 square contains A, B, C, D, E, F, which are replaced from integer belong to integer 1 up to 9. Inclusive, so integer can be repeated. There are n ways to complete the squares as sums of the integers along the row, column, and two main diagonals are divisible by 5, right? So that means this one is divisible by 5, divisible by 5, divisible by 5, divisible by 5, 5, 5. So we need to focus on this one, right? Because here is a 5, right? So you can see if I fix the A, right? Basically, H I can write as is 5 is divisible by 5, right? Basically, H is basically is negative A, right? I'm using the congruent, right? For example, -1 is 4, right? So that means also equals to 9, right? So it doesn't matter as long as I write as congruent, so I can write negative value, right? The D, that means this is negative D, right? So basically we can reduce the variables to C, right? So what we can see is here's a A, here's 5, here's negative A, right? Here's a D, here's a 5, here's negative D, right? So you can see A and a D, right? So negative A and negative D, I need A plus D, right? Everything is a congruency, okay? So this one I need to be 0 is negative 2A minus D, right? This I need congruency is 2A plus D, right? This one I need congruency is negative A minus D, right? So you can see after parameterization, right, we only have 2 variables, right? But we have another additional, this is the 2 variable, this is the freedom, right? And we have another freedom is the congruent, right? Okay, so you can see, for example, between 1 to 9, right? The congruency to 5, we only have 5, right? Congruency to 1, we have 1 and 6. Congruency to 2, we have 2. Congruency to 3, we have 3 and 8. 4, we have 4 and 9, right? Everything has 2 except for the freedom of this. That means we need to separate the congruence of 5, right? So in order to satisfy that, let's see, is we have the A is the congruence of the 5. That's case 1, right? Case 1. Then D is the congruency of the 5, right? If they are all the 5, everything else supposed to be 5. That's only one count, right? Then we have case 2. You can see we either is A congruence to 5, D doesn't congruence to 5. This one we need to times 2, right? Because we have D congruence to 5 and A not congruence to 5, right? If A congruence to 5, D cannot congruence to 5, right? So A and A plus D cannot be congruence to 5, right? The A plus D cannot congruence to 5. So in this case, that means A is 5, right? B is not congruent to 5, so B has an original, we have 9 choice, we must take out 5. So we have 8 choice here. Right, the A plus D, because it's not congruent to 5, we have 2 choice. right? Here is A is 5 is single choice, is single choice. Now we need to see whether 2A minus D can be congruous to 5, right? Because A is congruous to 5, that's 0, and D is not, right? So that's why this one also has 2 counts, right? So the total of this counts is 8 times 1, 2, 3, 4, 5, 2 to the 5, right? Is 2 to the 8 is 256, right? That's one thing, and the other opposite thing, so we have 12. Okay, that's the case 2. Now we have the case 3, right? The case 3 will be A cannot be 5 and the B cannot be 5. Right? Okay, that means so if A cannot be 5 and D cannot be 5, right? So basically we have a choice of if A plus D is 5, right? So the first choice, if A plus D is 5, then 2A plus D is A plus D. This is definitely cannot be 5, right? Okay, if this is the case, right, basically we have how many choice for the A? We have 8 choice for the A, right? We have, okay. Because we have the A plus D needed to be congruent to 5, right? So for everything, for if you pick, for example, you pick 1 here, you pick either 4 or 9 over here, right? So we need to only have 2 choice here, right? Yeah. If we have 2 choice here, then the A plus D is congruent to 5, right? So here is only 1. Here is only 1, right? Then 2A plus D cannot be congruent to 5, then this everything has 2 choice, right? Then the negative A is not congruent of 5, right? So this one has 2 choice, right? And this one has 2 choice, right? That's case 3.1, right? Okay, what's this? Is 2 to the 3, 1, 2, 3, 4, 5. Okay, so we have 3.2, right? That means how about the A plus 2D, 2A plus D, right? Is congruent of the 5, right? So this is a very similar case, right? So basically, if A has a choice, right, not congruent, the D cannot be congruent to 5, right? Basically, D, you need to make this happen, D has 2 choice, right? And basically, here is this one has 1 choice, this one has 1 choice, this one has 2 choice, right? This one has negative D has 2 choice, negative A has 2 choice, right? This one is 2 choice. So this is symmetry is 256. So the last one, right, is 3.3 is A plus D also not congruent 5, and A plus 2A plus D also cannot be congruent, right? Now what this one happen? We need counting, right? So if A is fixed, A has 8, right? So if A has 8, right, we know we have 2 kind of D, right? can be congruent, right? And also we have 2 of the D can make this happen, right? Okay, so if we have 2 and 2, then D is 9, take out 5, that's 1, and take out another 4, right? So that's only 4 choices, right? If this one doesn't happen, everything else answer 2, right? So what that is 2 to the 3, then 1, 2, 3, 4, 5, 6, 6, then 2 to the 8, right? Is 2048, right? So basically, if you're adding all the case up, we have 2048, 512, 512, and 1, right? So with that, so that's 3, right? 1, that's 73, right? So the final answer is 73. Okay, so that's it for all of the Guass, the AMC mock test. I think this is a very good test. And yeah, and thanks a lot. And thanks for your watching and your time. Okay, thank you. Bye-bye.